Good day, everyone. Today we're talking about rubric and logarithms. Alright, in the video, I'll be diving deeply into Project 4, Academic Dishonesty, and Intro to Logs. Alright, rubric for Project 4. A few of you guys are working on it. Some of you guys are just rushing through it just to get it done. And you may need to be careful about it. Alright, the rubric for Project 4 is this. Student paraphrase, put in their own words the precise definition of mathematics and explain how the mathematician satisfied the definition. So by now you guys should know the precise definition of mathematics that I taught you guys in class. So you should know it by now. So what you have to do, you have to take those words of each part of that definition, such as count, ordering, measuring, and you have to put in your own words, what does this mean? Now, the word count, which is part of the definition of mathematics, that may be hard to, paraphrase. You could just leave it as count. But I know for a fact the precise definition uses a lot of future tense like ing and stuff like that. So you just have to just paraphrase. You could use word to count, but what about cipher? What does it mean to cipher? You gotta analyze that. What does it mean to build models around the environment? You have to break that down. Alright? And again, make sure that you could explain how the person satisfied the definition of mathematics. So I am looking for accuracy, so don't give me just anything. Alright? Student paraphrase. Again, put in their own words of the information of the mathematician. Birth, life, mathematical education, and death. So again, yeah, please don't copy and paste. As you guys saw in project number 3, most of you guys' projects I didn't even grade because, well, I gave you a 0 because you copy and paste. That's not your work. Alright? Students discuss what did the person do to improve life by invention or academics. So if you're looking for a mathematician who created the pencil, just throwing out an example. Okay, how did the pencil improve life? Alright? And do not forget some of the ELA stuff you learn in ELA classes. I will also be grading you on that too. So make sure your stuff makes sense. Student presentation must be easy to read and organize. This that you see right now is a presentation. So make sure you don't put no bright words and pictures behind words or making it hard for the person to read. Again, do not forget, you are presenting, so you have to present your best. Writing is no longer permitted. So now, for those who did wrote, which not many of you guys did, you got to put in a slide. I can no longer allow you to write. Only because you guys struggle real bad of writing paragraphs. And by now you guys should know how to write paragraphs, but you struggle with it. So, in addition to that, some of you guys handwriting, when you write it out in pen, it's difficult to read. So, I can't do that. Alright, now let's talk about something serious here. Academic dishonesty. I spoke to you guys about this throughout this semester. because I told you guys this semester everything's going to be a little bit challenging because I am looking at things a little bit more detailed. So you guys, as I've told you in the classroom, you have to have academic integrity, meaning that you have to have things in your own words. In addition to copying and pasting information. No, I know it's easy to do to copy and paste, put stuff, in a slide because you don't want to type it out yourself. However, you are not allowed to do anything like that. When you copy and paste the information from Google and putting the information into your own work is academic dishonesty. And most of you guys have did that after I begged and pleaded with you guys not to, and I told you guys it has to be in your own words because these projects that we are doing is based on your own words. All right? So let's try not to do that no longer because these projects which you have plenty of twice a month, you won't get struck down every time. All right? Typing information word from word into Google. From Google. So, like, say for example, you saw some information on Google and you just typed it word from word from what you saw on Google to the slides. That is also academic dishonesty because, again, you're taking information from Google instead of giving me what you have learned from Google. All right? Taking information or ideas from anyone is also that. So, like, if someone got some information and you taking it from someone, even the ideas, academic dishonesty. Because when I do these projects, I'm not looking for how similar you guys could sound. I'm looking to know each and every last one of you. Can't do that if you're giving me someone else's work or someone else's ideas. I can't condone that. So you may want to be careful of that, especially when you try to work an individual assignment as a group. Like these projects, almost all of them, unless I say otherwise, are individual work. So that means 10 or 20 people should not be working together. No one should be working together on these projects because it's you telling me stuff from what you research I need to know about. All right? So again, ELA, let me write that down somewhere. ELA, writing is talked about. So the ELA rules. So we may have to, bow to that. Again, many of you guys will be going to college or will be doing something of a similar nature. When you copying and taking stuff from people, that's being dishonest. So it's stealing. Academic dishonesty is stealing someone else's work. Even if they gave you permission, it's not your work. All right? And the ELA class have taught you how to give credit to people who you got information from, but we could discuss that later. All right, announcements. I want to give this particular student a shout out, Mr. Fisher, for improved participation. So, you guys, one of the things that I always look for is that participation piece. Like, are you truly engaged to the questions from A to Z? How often you are on your phone? How you are really focused on the material? I, this student has been really trying to make sure I know that he's talking. He's even being honest about the work. So when he said, "Oh, I got this wrong," He's telling me this. He's not hiding behind photo math. He's letting me see who he is. And for that, I will add bonus points to that grade. Tutoring is no longer happening. So look, y'all, as I told you guys, sadly I can't do that no longer. Especially the way as how I've been doing it. Because one of the things that has been talked about, as I said before, you guys are not really taking the tutor and really trying to grow from it. You guys are only there just for points. And few of you guys come to do that. So, as I told you, you have to show me how bad you want it this semester. If you can't show me, you're going to be in this course again. Alright? 3-day policy in regards to my work. When it's late, I do take off. Day 1, 10%, day 2, 15%, day 3, 20%. After the third day, it is a 0. And I do not look back on work like that. Remember, when you are absent, it is your responsibility to reach out to me and to get makeup work. You yourself. I don't care if you tell me, oh, I was absent. You still got to talk to me about getting makeup work. If you have not done that, you still got a 0. ACT rotations are happening this week. And yes, you will be using a lot of line paper I have in class, so we're going to be wearing it out. Intro to logs. Previously, we've been working with exponential functions. But before we did all that, we talked about exponents. So we know that exponents is repeated multiplication. So 2 to the power of 3 is saying 2 times 2 times 2, which gives us 8. Oftentimes you guys see 2 to the power of 3 as 6, which you know that's not the case. It's not multiplication, it's repeated multiplication. You're taking the 2's and you saying 2 times 2 times 2. So you're taking 3 sets of 2's and multiplying them. So it's not 2 times 3. So be careful of that, because that oftentimes mess you up. Alright, the next order of business we did from there. So we talked about exponents, but then we talked about the law of exponents. Now we know that 2 to the power of 3 times 2 squared, when we multiply together, is going to be 2 to the power of 5, because when you multiply, you add. So 2 cubed over 2 squared, we know for a fact we subtract them. 3 minus 2 equals just 2 to the first power, or just 2. Right? We know from there, going back to the law of exponents, we know that we have, I'm using a variable here, we know you multiply those together, and there's going to be x in times m. Alright? We know from there, when we have a negative exponent like 2 to the power of negative 3, we know that we have to rewrite that as a fraction or a rational number. Again, fraction is elementary language, so we in high school, so rational number 2 in the denominator, and then that negative 3 becomes positive 3 put in the denominator. And then from there, we talked about x to the power of 0, anything to the power of 0 is 1, and we also talked about if I have a square root of any number, I just chose 7, but let me use x to represent any number, because in algebra, letters represent any number. It's going to be x to 1/2 power. Anything with a square root has a half power. Then from there, we know that we hit x to the power of 3, but we have no numbers right here in the front. We know we could rewrite that as x 3, because there's no number right there. This always has 2. Alright? And then to finalize this, what if I have x 5 3? So when I have that going on, I could rewrite it as x. The denominator is always going to be in the front, 5, and you put it over 3/5. Alright? So we just went over the law of exponents. Alright? And we was given problems that looks like this. Alright, so we have something like this, and we have to use the series of law of exponents. So let's do it. So the first thing we have to do to make things easier on ourselves, just like the order operation works with anything with parentheses. So this number multiply all, which is x 4th y 6 over x 5th x to the power 0. Alright, now from there, since we have division, we gotta use subtraction. Well, before that, we gotta look at this problem. Again, y to the power 0 is just 1, and 1 could just disappear. So that's gonna be x 5th equals x 4th y 6. So those x's are the same, and because they have written as a rational expression, why don't we not just subtract them? X 4 minus 5. 4 minus 5 equals x to the negative first power. It got y 6. Now, before we finalize our answer, since we know that x is negative 1, we can do this. This is going to be my final answer. And I put this dot to let you know, okay, I'm done. Y to the 6 because it's positive, and x 1 because I took this negative exponent I put in the denominator, which makes it a positive. And we know that anything that is to the first power, you don't need the 1. You could keep it, or you could get rid of it, because it's understood to be 1. Alright? And that's... Oh, we got one more thing to talk about, then we can move on. Then, we have this situation when we were solving equations by hand. Alright? So here, the bases are not the same. In order for us to do this by hand, we have to do this. We have to put 9 because we gotta make these 3's have the same basis. I'm sorry. There we go. The basis gotta be 3 because you always want the small number because 3 is a prime number and you want them to be in primes. So 9, you could rewrite it as 3 times 3. 3's are prime numbers, so I had 2 3's, so that's 3 squared. Alright, now that it's saved, now we could solve it. Well, we gotta drop the exponent, the basis. X plus 6 equals 2. Subtract 6 from both sides, subtract 6 from both sides, and x equals -4. Bam! I'm done. That's what we did so far with exponents. Now we get into something else that still uses the exponents, but we're going to deal with the inverse of those exponents. So we're going to be dealing with the inverse. Going back to that math problem we just did to solve that equation, when we were trying to find 9, right? Well, let me put the equation up. So it was 3x plus 1, or something of that nature, equals 9. So in that type of problem we did, we were trying to figure out 9 and how we're going to make it to be the same base. So we know that 3 to what power gives you 9. And what we just did is called a logarithm. So a logarithm is the opposite. So logarithm is pretty much just saying that we answers right here for this problem. 3 to what power gives me 9? And the answer is 2. Okay, so when we rewrite this in a logarithm form, we do this. Log, take your base, which was 3. Alright? Take your answer from the exponent that we did, 9. So when you see this logarithm right here, it's asking you how many 3's does it take to give me 9? And we know by doing the exponents, 2. Okay? So let's try another example. So if I have log 2 being my base, and I have 8, well, I'm asking you with a base of 2, and my answer to be 8, I'm asking you this. How many 2's did it take for me to get to 8? And you say the answer to be 3. Alright? 2 to the power of 3 is 8. And the log base 2 of 8 is 3. Alright? One more example, then we go on. So, if I have log base 5, 125, what would that equals to? So again, I'm asking you 5 to what power is going to give me 125. 3. 5 cubed is 125. Alright, not too harmless, huh? Perfect. Alright, now how to evaluate this? Sometimes you're going to deal with problems like this where you're not going to have an integer to deal with. So this is asking you 2 to what power gives you 5? And we're talking about integer. Well, there's none. You know it's going to give you some type of, it's going to end up being some type of real number that we don't know about. So when you're dealing with that, and real numbers are fractions, well, rational numbers. Don't forget about this. Real numbers are rational numbers. It could be integers too. So, and again, a rational number is equal to a decimal also. Remember, all fractions could be written as decimals. Anyway, so put the stuff in decimals, the app, and you get your answer. Simple. Don't even waste time on it. And again, that's only when you cannot find a integer exponent. Let's move on. So guys, now here's a definition that you need to know. But before we go to this definition, if I say f of x equals 2x, what I am saying is very basic. Y equals 2x. F of x is more of the algebra 2 term that we will use. Y equals 2x, that's a very pre-algebra, algebra 1 skill. Alright? Now with that being said, let's go talk about a logarithmic function of f of x equals log base of x has the same definition for the base b as the exponential function f of x b, but with inverse characteristics. Alright? As some type of function, so from looking at these graphs, which one's going to be the exponential graph? Which one's going to be the logarithmic graph? This is the exponential, and this is the logarithmic. Let's look at them. They look pretty similar, don't they? Except for they flip over. So that just means they're just inverses of each other. Alright? The rational function, that's what this is. We will talk about that later, so don't worry about that. I'm only worried about the exponential and the logarithmic function. But today is all about the log. Alright, so we know that by looking at this, the log function is inverse of the exponential function, so we should talk about its characteristics. So what are the characteristics of the exponential function? The domain, range, the asymptote, and the y-intercept of the exponential function. Guess what? For the logarithmic function, all these characteristics are going to be the same except for the logarithm don't have a y-intercept. You're going to be dealing with the x-intercept. And we are almost through this video, y'all. So here, the domain, let's look at it. Again, the domain is all the x values. And then if you get the range, it's all the y values. So let's talk about the domain of this logarithmic function. So, where does it appear to start at? So if I was to draw a line, because again, I'm going for the x-axis, it looks like it starts from 0 to infinity. The range of this is going to be all real numbers, negative infinity or positive infinity. The asymptote of this. Now, here's the difference between logarithmic and exponential functions. The asymptotes of this is going to be the opposite. In the past, when we did exponential functions, we found them by drawing horizontal lines here. So, will the asymptote be 6? No. Will it be 4? No. Will it be 2? No. Will it be 0? Nope. 2, 4, and we could keep going horizontally, but we won't be able to find the asymptote that way. So, this particular asymptote, for us to find it, it's going to be vertically. So let's go through it. So when you graph this, it is going to touch 14. You have to just graph this yourself. I took this graph for decimals. I screenshot it here. 12 is going to touch 12. It's going to touch 10. It's going to touch 8. It's going to touch 6. It's going to touch 4. It's going to touch 2. 0. It's not going to touch 0 at the moment. But as we draw the line, at some point it will. So that's our asymptote. And then our x-intercept, because you do have one, is going to be 1. So now I challenge you to compare and contrast both exponential functions and the logarithmic function we just did. How would you find the asymptote? So which of the characteristics tell you about the asymptote for the logarithmic function? That's one question I will help guide you. And I'll leave you from there. Transformations. You did these before. Transformations are pretty easy, except for when you're dealing with left and right. So, when the graph goes up, the blues being the original, and the red is the transformation, goes up when D is positive. But when D is negative, it goes down. Just keeping this in mind, it's not hard at all. Transformations you guys do well on. So this is when it gets confusing. When in the inside it goes left and right. So in your mind when you think positive, you want to say it's going to go when you saying that it's positive, it's going to be right. But unfortunately, when it's positive, the graph actually go left. Again, this is the original, and the red is the transformation. So it went left. Again, Why is that? Well, let me ask you a question. Well, not questions, just a piece of advice. Look at how we solve equations. When you see x plus 6, why is that not in the positive side? Well, x plus 6 equals 0. So why is that not on the positive side? Why is that not on the right? I want you to find out by using that. Alright, on the right, that's when things are negative. So again, ask yourself a question. Why is x minus 6 equals 0? Does not stay in the left, it's minus. So why is it on the right? Alright. Now let me ask you a quick question. I end it here. Yeah, how's my presentation? My organization? My words? The reason why I'm asking you this only because I need for you guys to understand copying and pasting and putting stuff that is not in your own words, not getting credit to people, is academic dishonesty. And we can't condone that. That's pretty much it for the lesson. It's not hard at all. Alright, homework. You should definitely check out Math Nation. You should be checking out Session 9. I believe topics 8 through 12. Alright, that should be it.